Hello, everybody. So today I'm going to talk about SOASTA. So I work for SOASTA. We deliver 3 software products, and we're going to look at how SOASTA can feed into the continuous testing cycle, ensuring quality through the continuous delivery life cycle. If we think about today's technology, applications, user expectations are much changed. Impatient consumerism drives rapid app development. We've got mobile and web technologies, and this is really moving away from the PC-based type development cycles that we would have used a number of years ago. Everybody is online. Everybody wants everything straight away. Unprecedented scale as well. So people want to have access to your applications, and it's very hard if it's a public-facing application to necessarily know exactly what that scale is going to be. Your application could be an absolute hit, and you could get a lot of traffic being directed to your site more so than you were expecting. And people expect availability to be there all the time. 100% availability is a key. Complexity as well. Apps are becoming more and more complex. We've gone away from a very simple client-server type model. We've got composite apps where we're pulling in lots of information from different applications within the organization. We're pulling in information from third-party services as well. And lots of different APIs interacting. So there's lots of moving components and lots of bits in your application that can make the application a lot more complex. And rapid delivery, agile development, continuous delivery, fostering the DevOps principles where the cycle to release software is very quick, and getting people through that cycle is very quick. And the demand from the consumer point of view is very quick as well. The key thing here is that all your users, be they internal users within an organization or be they public-facing, are all consumers of your application. And the demand for the applications is very high. Just to go back to that previous slide, one of the key things that we're talking about here is really the consumer-driven demand for applications that need to be tested in a very fast cycle. Testing cycles typically can on a legacy type system can take weeks, months. Nowadays, testing cycles have to take a matter of hours. So it's really bringing down the complexity of the tests that we need to run. So CI offers speed of continuous delivery. What's not to like? Small batch sizes. Small batch sizes simply means that we're making smaller little bits of code, smaller bits of functionality that we're delivering. The smaller the piece of code and the smaller the batch, the smaller the change that we make, then the less complex it's going to be and the easier it's going to be to manage, test, and deploy. Comprehensive version control. So the ability to use versioning control effectively within the continuous delivery cycle. Versioning control gives you the ability to have a repeatable test environment, a repeatable set of code that can be deployed. And it can apply to not just code, but it can apply to configuration files, to environment settings. And it all goes in towards the cycle of making sure that the build quality and the test cycle itself is going to be more effective. Automation, a key part of this process, automating everything from the build of the code through to the testing and feeding back the results to the developers themselves. Continuous feedback, a key piece of the continuous delivery cycle. So the ability to build the code, deploy, test the code, and feed back the information from that test back to everybody involved. So back to the testers themselves, back to the developers, back to everybody who's involved, that they can very quickly and very easily see what is going on in that process. They no longer have to wait for 2 weeks to get the outcome of the test that were run against their environment, so they can see almost instantaneously what's happening with that code that was put through. Emphasis on working builds. See a lot of organizations that go into the testing cycle and they uncover bugs as a result of their testing cycle, and then they continue to make changes. They continue to deploy code and make changes into the application, and those bugs simply rot in the system and make the job more harder further down the line. I'm sure you're all aware that the further down the life cycle that we fix bugs, the more costly it's going to be, and the more hard it's going to be to actually fix those bugs as well. So emphasis on the working builds. Essentially, when we uncover a bug, no more code is promoted and no more code is deployed until those bugs have been fixed, and then we can continue on in the testing cycle. Consistent environments. With the advent of cloud technologies, it's very, very easy to deploy environments, very easy to control and quickly spin up environments as and when we need. And these don't have to be large environments. These can be a small environment. So it could be an environment that's simply going to run 5 users. It could be an environment that's going to run 5,000 users. But the ability via CI to configure and deploy consistent environments ensures that your testing is repeatable, is accurate, and is very useful to the organization itself. Developer, tester, ops, collaboration. The whole idea of promoting the development and the collaboration between the teams. So no longer is the tester simply running a bunch of tests and then feeding back, running the test in a silo and then feeding back the results to the developers. The developer and the tester are working hand in hand. They're familiar with the code that's going in. They're familiar with the types of tests that have to be put together to execute that code. And the continuous feedback and the collaboration between the two teams is key. So, SOASTA poll. This was a poll we did after a continuous integration of CloudBees webinar. Which best describes your status with continuous integration? Building all apps using CI, 20%. Building some apps using CI, 32.6%. And you can read the rest. Implementing CI soon. Terminating CI is a good option. And 14%, what is CI? Excuse me. So we can see that the full-scale model has not been adopted readily across organizations. This poll was approximately 100 different organizations that we queried. Obviously, the maturity of an organization, the maturity to adopt that CI and the continuous delivery cycle has a large part to play in this. But we can see that it is still quite low. So apps have evolved. The process of deploying apps has evolved. Testing really hasn't. Testing typically takes weeks. Scale is limited, and often it's seen as very, very expensive. So traditional testing tools are costly. To get to the scale that you want with some of the more traditional testing tools cost an awful lot of money, and it prohibits really the adoption into a continuous delivery type of environment. The idea with SOASTA is that we're trying to reduce that life cycle. We're trying to reduce the speed of the test itself so that the testing becomes much, much shorter, much more effective, much more focused, and the feedback into your team is much quicker. Testing has always been seen as the bottleneck. Excuse me. So the development is going through and it gets to the testing phase, and the testing piece is the area that it slows down. The testing piece is where the time is spent. There's maybe not a lot of information flowing back from the testing organization, and that area is seen as a bottleneck. I've spoken to a number of you today, and you've been telling me that testing does happen in the organization, but you're not really sure how effective it is. It takes a long time to happen. One guy said to me that the testers left, they've still got his test scripts and they still play them back, but they don't really know what they do. So it's pretty ineffective, and testing has always been seen as that bottleneck. We want to change this, so what's been missing? Mobile test automation. With SOASTA Touch Test, you can deliver mobile test automation. So this is testing on real devices against your applications in an automated way, building out automated tests that are robust, reusable. They're at the object level so we can really understand exactly what's going on. Real test devices. A lot of testing solutions out there test on simulators, test on virtualizations. We test on real devices. Okay, so actual devices that your consumers will be using. These devices aren't jailbroken, they're standard stock devices. Touch Test is the only solution that currently offers a fully automated solution for the iPad mini. So your users are going to be using those devices, then you should be testing on those devices as well. Performance testing. Performance testing has often been seen as a test that happens later in the life cycle, towards the end of maybe the integration tests. Then we'll step into performance testing, and it's generally a big test. It's the sort of user numbers that we'd expect on our production system. Performance testing can happen much, much earlier in the life cycle. It can be part of your continuous delivery framework where we test at much smaller levels, and that can be something as simple as testing a database routine for 50 users or 100 users, checking the concurrency on that. Excuse me. So performance testing absolutely can become part of that cycle as well, and can become earlier in the life cycle itself. And solid integration. Solid integration with Jenkins enables us to really build and close that whole loop where you can, the code gets built, you deploy the code to the devices, you test the code, so you functionally test the code, you then run your performance test, and the information is fed back seamlessly into the CI framework. So the integration with the tool is solid, and you can see, and everybody in the team can see exactly what's going on and the information that they're getting back. So laying the foundation, the example process, an assembly line process, functional testing, does it work as designed? So we're checking that the application as it was designed, as it was specified, does actually do what we're expecting. Does it perform under extreme circumstances? So our non-functional testing. What happens in actual conditions when it's out in the wild, and then we can approve and continue that cycle. And this cycle is an iterative process, and the same applies to our continuous delivery, our continuous quality process. So we build the code, excuse me, we execute our functional tests, so we're verifying that it's functionally doing what we expect it to do. So the users can log in, the users can search and find the data that they want. We then run our performance tests, our reliability, our scalability tests to ensure that the application will be able to handle the load as we expect. And then we can monitor what happens in real conditions. And again, it's an iterative cycle. We'll step back around again and we'll run that through. And it'll be a very, very quick and easy cycle. So mobile test automation. We do this, our software is called Touch Test, and basically what we do is we take a build file and we make it touch testable. So we put a little bit of our own code, a little library into the application, and that gives us access to the application at the object level so that we can interrogate the objects, we can get to all the properties of the objects, and we can build out robust, reusable test cases against those. All the sort of gestures that you would expect on a mobile device, so pinch, pan, zoom, any custom gestures that may have been built into the device are also fully supported as well. So it's giving you the ability to build out a robust, reusable test case that is 100% like your users would be doing. It's not cutting corners. It's not doing it on a simulator or anything like that. It's going to be on the actual device. Reliable, maintainable test maintenance and test automation. Part of the ethos with our platform is that we build tests that are in a modular fashion, so that we build tests that are small bits of functionality, and we can reuse those little bits of functionality time and time again. So we can build out a test that does a login, that does a search, that does an add to cart, and then does a purchase routine as well very easily. Stability across mobile OS platforms. So we're testing across all of the OS platforms, iOS and Android, to ensure that you've got stability and you've got coverage in your testing across each of the platforms itself. Device performance measurement. So whilst the tests are running, you're getting continuous feedback in the touch test software of what's happening on the device. So you can see the memory, you can see the network consumption, you can see the CPU being consumed at those given points in times when you're carrying out specific actions and specific tests within your application. And real-time feedback via continuous integration. As it's running, and once it's finished, then we feed back directly into Jenkins exactly what the test results were, whether it passed or failed, and whether that build can pass or fail itself. We have a couple of offerings, private device clouds. So private device clouds, fully managed device cloud installed behind the firewall. And this is a device cloud of real devices. So this is giving you the ability to execute your tests within your organization against the devices that your consumers and your users are going to be actually using against the application itself. Real-time device inventory, status, and availability. So there's a management interface into the devices themselves, so you can see the current status of those devices, and you can access those devices as you need to execute your test. 24/7 secure remote access to the devices, so you have complete control. So you specify what the devices are, and you have complete control of those devices, and you can run manual and automated tests. Automated tests, obviously, with touch test. Manual tests on those devices, because there will always be manual tests. There are some circumstances that you can't step away from, and you still need to do a few manual tests. Remotely access to selected mobile device and any mobile app. So the app is deployed to the device as part of your build cycle. We then run the tests against that, and you've got complete control over that process. The private device clouds, the devices can be provided by SOASTA, or the devices can be your own devices as well. So you've got complete control in that. In addition to the private device clouds, we also have a public device cloud, which is a dedicated public device cloud. We do this via a partner organization. It gives you access to all the latest devices, so as we know, devices are continually changing. There's more devices coming out, there's more variations on them coming out, and the public device cloud gives you access to the latest builds and the latest releases of the software. Automatic installation, maintenance, and upgrade. So the devices themselves are maintained and managed for you. The devices are hosted in a secure data center, so there's no security issues. You will have dedicated access to those devices. You will be the only person in your organization using those particular devices. Key thing is these are stock devices, not jailbroken devices. They're not rooted devices. A lot of the testing solutions that we see out there, particularly for mobile functional testing, have to have a jailbroken device or have to have a rooted device. And that causes big issues, obviously. You want to test on the real devices that your consumers are going to be using, and we can do that via non-jailbroken devices. Seamless integration with touch test and CI environments. So the ability to integrate seamlessly into this process, so we feed back directly into the process of success, failure, and the test results are there. With touch test itself, it's a very, very feature-rich dashboard, and you can see a lot of information coming back about your tests. There's an API available to install the apps, to reboot, wake up the devices, launch the devices themselves. With our Jenkins integration, for example, we have the ability to, with just a couple of build steps, to make an app touch testable. I inject our library of code into it, to code sign it, and then to run a test against those particular applications. So it becomes a very seamless process and enables 24/7 automated mobile regression testing. It's really shortening the cycle in the testing. Excuse me. So the other area is cloud testing. So cloud testing is our performance testing. Cloud test is our performance test tool, and performance test tool gives us the ability to, at any stage through the life cycle, test to particular scale and to particular loads with different bits of functionality. If we look at this graph, we're talking about three different environments: test lab, staging, and production. And at each level of those testing environments, then we're going to uncover different types of issues. So in the test lab, memory leaks, slow pages, methods, inefficient database queries, all the sorts of things that you will uncover with small unit type performance tests are going to be done in your test lab. We move it out to staging. Then you might see some issues with third parties. You might see connection pools exhausted, that sort of thing. And then fully out into production, where you're going to be testing your users as your users would come in. And it's key to test the whole way through each of these phases. You can't skip them and just jump straight to production testing or just do the test lab testing. It's important that we do all of the tests. When we're in the production level, it's the only true test from your consumer point of view. You're going to be coming in through your outward-facing load balancers, firewalls, touching on CDNs if you're using CDNs. All the components that your users will interact with will be tested as part of your performance test. So our cloud computing for end-to-end performance testing, Cloud Test itself is the name of our software, and it's not just for testing cloud-based apps. It's just that we use cloud infrastructure really to run our software and often to inject the load from a truly external location. So over on the left-hand side, we have Cloud Test itself, which is made up of a number of components. And the key thing with Touch Test and with Cloud Test is that it supports a very collaborative approach. So everybody can access this environment. It's simply accessed via your browser, and you access it and you can log into it, and everybody can take a different view of a test running. So a DBA might want to look at specific figures coming back about the database. The test manager might be interested in the throughput and the response times and the error rates. Everybody can access that same environment and distill their own view and their own set of metrics that they're really interested in. In the middle, then we have the SOASTA Global Test Cloud. We have access to over thousands and thousands of servers worldwide, approximately 50 different locations that we can inject load from to test the application. And this is truly external load. It's coming into your external-facing firewall through your load balancers and hitting the application as we would see. Whilst the test is running, it's very, very important to have good feedback of what's happening during the test. Obviously, we'll get a lot of information back about the base level test metrics, so the transactional throughput, how many users we have in the system, what the error rates are. But we also need to know what's happening on the back-end servers, and we achieve that via monitoring of the servers themselves, which we can do in this instance here via what we call a conductor, which is a little piece of software that sits inside the firewall and gathers metrics from the servers and passes them back out as required. The performance testing here obviously suggests that we're running very, very large tests. That doesn't have to be the case. We run tests from a couple of hundred users through to hundreds of thousands of users. It really depends on the situation and what your application is meant to support. So continuous quality, much more than unit testing. So I just made a code change into Jenkins, run the unit test as normal, spin up a suitable, consistent test environment in the cloud or in the lab. So the ability, if we go back to one of the first slides where we were talking about versioning control, the ability to continually bring up a test environment that is consistent is key to the success of your testing. If your environment is consistent, then you know that the environment's not necessarily going to be the issue, it's not going to be the problem for you, and your application test can run on there. Run iterative load tests via Jenkins. So iterative process of running our test to uncover scalability issues, performance issues, connectivity issues. If we're using mobile apps, then run our functional automated tests on real devices for functional and performance validation. The validation the whole way through in the functional test is there the same as it is in the performance test. So we're verifying the functionality and we're validating the functionality under load when we're running our performance tests. We feed directly back into Jenkins, so a picture of the Cloud Test dashboards here where we're passing back that information about what happened during the test itself. And this is supporting that collaborative approach where the developers and the testers are working together and very, very quickly and easily getting the information back that they need to know. Manage to a performance baseline. We establish a performance baseline so that you know, okay, at this particular build, my application performed in this way, or this stored procedure performed in this way. And as you go forward and deploy more builds, then you can run essentially a performance regression test to establish that baseline again and confirm that you haven't deteriorated in your performance, or indeed if your performance has got better, if that was your aim. So you're establishing a baseline for both performance and your functional testing. And then we can use real user data to iterate dev and test plans. The introduction of the real user data is with another product of ours, which is a product called Impulse, which is a real user monitoring tool. And that gives you the ability to understand for 100% of your users, 100% of the time, what they're doing on your app or what they're doing on your device. So you can see if performance is poor from the United States, if the performance is good in Germany. You can see what types of browsers people are connecting to your site with. And you can build out business metrics as well to understand exactly what is happening in relation to the business. So it could be something as simple as the number of people registering on my site, and you can see if the site performance degrades, does the number of registrations drop off. So it gives you very, very valuable information, and that information can be then used to feed into your test cycles as well. So if you know your demographic, then it makes it much, much easier for you to build and plan more effective tests, particularly with your performance tests. A lot of the time with performance tests, when we are working with customers, the question of, what's the volumetric? What do you expect? Okay, nearly there. What do you expect on your site? Then a lot of time people don't know. People simply don't know. By using Impulse, we can feed that information in directly, and then we can say, okay, well, this is your concurrency, this is your throughput. It goes up at 6 p.m. in the evening. It's very useful and valuable information. There's a dashboard, real user data dashboard. We've got the globe, which shows the beacons where people are connecting for, and then information such as median load time. We can see how much traffic we've had, so 848,000 page requests, and then it's broken out by page groups, countries, etc. as well. And this is just one of the dashboards that we have available within RUM. So continuous testing distributes effort. The more traditional cycle, we had unit testing, through the development cycle, then functional testing, through to performance testing, and then into live. With continuous testing, we're shortening that cycle. We're given the ability to include very, very focused, accurate, robust tests, be it functional or performance, in that DevOps process, where it becomes a very, very iterative process of building, testing, deploying, and passing or failing. Just one example of customer, a SOASTA customer. This was from FIS Mobile, who are a provider of mobile banking solutions in the US. They have over 25 million different customers. They have lots of different technology. They've won awards for their payments engines. They condense 4 months of manual tests, which run in 1 hour overnight. So the manual test process, where they have a bank of testers executing, prone to human error, and then feeding back that information into the cycle, has now been condensed into 1 hour. 25% reduction time and time to market for production rollouts. So you can see for yourself the savings that are there to be had. So 250 hours of manual tests running in just over 1 hour every night. We can run these on a bank of devices, so you can run a lot of tests concurrently, and this is where you'll save a lot of timing and a lot of throughput. Regression tests not run until feature complete, now run nightly. So running the regression tests on a nightly basis, and this is something we do ourselves within SOASTA as well. We use Jenkins, and we run approximately 400, a combination of functional and performance tests on a nightly basis. Fixing bugs earlier, detailed test results for the developers. Because we're in that cycle of continuous feedback, the developers know straight away where the issues were, and they can focus on those issues and those bugs and get them fixed. 25% reduction in market, and the overall process reduced field failures. So to finish, the path to continuous testing, understand your requirements. So know what you want to get to, what you want to test. Identify the cloud advantages for you. So use cloud technologies to spin up an environment and use an environment that is consistent and reusable. Automate the obvious and the most critical. So people perhaps look at the situation with automation and think, I'm going to try and automate absolutely everything. That's never going to succeed. So automate the highest risk and the most critical processes. Connect to a continuous integration process. And align teams with actionable information. Because that process is so quick and it's feeding back information into the development cycle, it becomes much more collaborative. The information that they're getting back is much easier to reuse and work with straight away. Okay. Any questions? Yes. So with the public cloud offering, we partner with an organization who provides the devices themselves. Don't provide any apps as such in the cloud. The apps come from your own development. We have both. We have both. The public cloud offering is secure. It's backed by the third party that we use for the provision of the cloud itself, and it is a secure, highly secure data center. So it depends a lot on the organization as well. So we have some banking organizations, some financial services who want to do it in-house, don't want the information on the public cloud. We have other organizations that do use public cloud. So we have a mix of both. Yeah. Yeah. Any other questions?
Thanks, Gareth.
Yep.